Welcome to Nardar Academy. In this video, we are going to discuss about area of plane regions. In that one, particularly we are going to discuss about sectorial area. Already one video is uploaded for area of plane regions in Cartesian coordinates. Here we are going to discuss about sectorial area. So here everything will be in terms of r and theta. Okay, right. Now the formula is area of the sector AOB. See, this is my curve r equal to f of theta, right? R denotes what? This radius vector, and theta denotes the angle, isn't it? So this is the curve. AB is a part of the curve, okay? And I want to find out what is the area of this sector, OAB. This is called the sector, no? OAB. The sectorial area I want to find out. So for that, here you see OA is subtending angle alpha with the horizontal, and OB is subtending angle beta with the horizontal. This is our theta. Theta is the angle subtended by the curve at any point of time. That is called theta, and the angle made by this OA is alpha, OB is what? Beta. Then the area of this sector OAB is equal to half integral alpha to beta r square d theta. Okay, right? Right, let's see some problems based on this formula. So before going to the problems, let us discuss few curves which are most probably given in problems. Okay, only when you know how to trace the curves, then it will be easy for you to do the problems, right? Okay, first one is cardioid. Cardioid, you very well know, it is in the form of a heart, right? Cardioid, it will take the general form r equal to a minus a cos theta. If it is like a minus a cos theta, it will be like this. Okay, it will be on this part of the diagram, and this total length will be 2a, and here this total length will also be what? 2a. So a minus a cos theta, it will come in the left side. And suppose if it is a plus a cos theta, it will come in the right side. Okay, the same thing, this length is 2a and this length is also 2a. Then suppose if it is like sine theta, a minus a sine theta, it will be on the lower part. Okay, it will be on the lower part. So here it is its orientation is horizontal, and here this orientation is vertical, right? Cos means what? It will lie horizontally. Sine means what? It will lie vertically. And similarly for minus means, that is a minus a cos theta means it will lie on the left side. Okay, a minus a sine theta means it will lie in the lower part. Okay, and a plus a sine theta means it will lie in the upper half. Okay, right. Then the next one is circle. We very well know the circle equation in Cartesian coordinates. Here, you know, r equal to a means it is the circle centered at origin and radius a. Okay, with center at origin and radius a units, if you draw a circle, that is denoted by r equal to a. Very simple equation for circle. And then suppose if it is r equal to a sine theta, r equal to a sine theta means it will be lying on the upper quadrant. Okay, right? It will come like this, right? And suppose if it is r equal to a cos theta, it will be lying on the right side. Okay, so these are the different circles we have. And suppose if you have r equal to a cos 2 theta or a cos 3 theta, see here you have to look at the number. If the number is even, okay, here it is an even number, no? So 2 times the multiple, here it is 2, no? Okay, so 2 2s are what? 4. So 4 loops will come, and it is cos, no? So it will come like this. Okay, if it is cos theta means it will come like this, and number is 2, so 4 loops you will have. Here it is a cos 3 theta. If it is an odd number, only that number of loops will come. So 3 means what? Only 3 loops will come. Okay, so the loops will come like this. See here cos 4 theta, so 4 means even number, no? So 8 loops will come. And 5 theta is an odd number, so only 5 loops will come. And then sine 2 theta, for sine also the same procedure, but the structure of the loop will be slightly different. That is the position of the loop will be slightly different for sine, but the same procedure. 2 means what? Even number means 4 loops will come. Here for sine 3 theta, 3 is an odd number, no? Only 3 loops will be coming. Okay, so these are the certain common things that you have to remember, so that it will be easy for you to find out the area, right? Let's see the problems. find the area of the cardioid r equal to a into 1 minus cos theta. Okay, so cos, so it will lie horizontally, cardioid equation, it will lie horizontally, and a minus a cos theta means it will lie on the left side, isn't it? So what's the formula? A equal to, see the area of the full cardioid they are asking. Instead of finding the total area, let me find out the area of the upper portion and multiply it by 2 because it is symmetric, no? Okay, so only the upper part I am going to find out and multiply it by 2. So 2 times upper part means here it is starting from 0, it is moving like this and coming to this one, no? That means what? 0 to pi limits, isn't it? First two quadrants, if it is coming 0 to pi, only first quadrant alone means what? 0 to pi by 2. So only the first two quadrants I am calculating here. So the limits are from 0 to pi. Finding the limits is also very important here, right? Half r square d theta. So r value is readily available here. Just you square it and integrate, that will give you the answer. So half into a square 1 minus cos theta the whole square d theta. So 2 get cancelled. So a square into 1 minus cos theta. See, the formula for 1 minus cos 2 theta is 2 sin square theta. So here it will be 2 sin square theta by 2 the whole square d theta. Okay, so 4a square integral 0 to pi sin power 4 3 theta by 2 d theta. Right, now let me take theta by 2 equal to 5 for simplifying the integration. I am taking like this. So that means d theta equal to 2 d phi. So theta equal to 0 implies phi is also 0. Theta equal to pi implies phi equal to pi by 2, isn't it? So 4a square integral 0 to pi by 2 sin power 4 phi 2 d phi. So it's equal to 8a square. Here I am going to apply reduction formula. Here the number is 4. So in the numerator you have to start from 3 end up to 1. So 3 into 1. And the denominator start from 4. And how many terms are there in the numerator? That many terms you have to write in the denominator. For reduction formula also one video is uploaded. Kindly go through that video for getting better understanding. Okay. Right. So 3 into 1 by 4 into 2. And again this is an even number, no? So whenever for reduction formula you get an even powers, you have to multiply that by pi by 2. So 3 into 1 by 4 into 2 into pi by 2. So the answer is 3 by 2 pi a square. Okay. Then the next one is find the area common to the circle r equal to a root 2 and r equal to 2a cos theta. See, r equal to a root 2 means it's a circle centered at origin and radius a root 2. And here r equal to 2a cos theta means it will be lying on the, lying horizontally on the right side, isn't it? Okay. So this will be my diagram. This is the first circle r equal to a root 2 and this is the second circle r equal to 2a cos theta. This common area which I have shaded, no, that I have to find. See, that formula I have given is there, no? That is the sectorial area. So here your shaded portion, actually the portion in the first quadrant and the fourth quadrant together will come. Instead of finding the entire region, I am going to find the area of the shaded portion and multiply it by 2 so that I will get the total area. Actually this area is also common, no? That will also come. I am going to multiply it by 2. Okay, that portion we will leave it. See this one part is bounded by this circle and another part is bounded by this circle. So what I am going to do is, see, area equal to sector OAB. Okay, sector OAB plus sector OBL. See, sector, what is OAB? OAB and then OBL. Right? OAB means what? See, OAB means it is the sector by the first circle r equal to a root 2. And then OBL means it is a circle by 2a cos theta. So half a square 2 d theta, here half 4a square d theta. Right. R equal to a root 2 and r equal to 2a cos theta. That means what? That is this limit we have to find out. No, both of them are lying in the first quadrant, but the limits are uncertain. So for that what you have to do is, see, both the equations, when they intersect, both the equations equate both the equations at the point of intersection. So a root 2 equal to 2a cos theta, that implies theta equal to 1 by root 2, that implies theta equal to pi by 4. That means the point of intersection is pi by 4. See, the first, they are lying in the first quadrant. Okay, that and they are intersecting at pi by 4. That means first integral has to be taken from 0 to pi by 4 and the second integral has to be taken from pi by 4 to pi by 2. Usually when you have any diagram in the first quadrant, the limit will be from 0 to pi by 2. But here you are having two different curves intersecting at pi by 4. So the limit should be taken from 0 to pi by 4 for the first integral. For the second one from pi by 4 to pi by 2. So here it is a square into theta within the limit 0 to pi by 4 plus 2a square into integral pi by 4 to pi by 2. Instead of cos square theta, I am going to write 1 plus cos 2 theta by 2 d theta. right? Let us integrate this one. So here it will be simply pi by 4 a square. Here it is a square into theta plus integration of cos 2 theta is what? Sin 2 theta by 2. So after applying the limits, pi a square by 4 plus a square into pi by 2 plus 0 minus pi by 4 minus 1 by 2. So after simplification, I am getting the area as pi by 2 a square minus a square by 2. Actually here I am finding the area of only this shaded portion, but one more portion is there below in the fourth quadrant. So for that, multiply the obtained area by 2. That will give you the total common area. So it's equal to a square into pi minus 1. Okay. Next problem. Find the area of one loop of the curve r equal to a sine 2 theta. So 2 theta means 4 loops will be coming, and a sine, isn't it? Okay, so it will be coming like this. So this also you have to remember for finding the limits. Okay, so what's the formula for area? Integral 0 to pi by 2 half r square d theta. If you get it in the first quadrant, simply you can take the limits as 0 to pi by 2. Okay, right. Now a square into sine square 2 theta. Instead of sine square 2 theta, I can write 2 sine theta cos theta the whole square d theta. So it's equal to 2a square integral 0 to pi by 2 sine power m cos power n d theta. Again reduction formula I am going to use. For reduction formula, first you have to start with sine power 2, no? So start from 1 in the numerator, 1 alone. So in the denominator you have to start from m plus n. 2 plus 2 is what? 4. 4, and then you have to reduce, but how many terms should be in the denominator? How many terms you get in the numerator? That should be equal to number of terms in the denominator also. Okay, so 1 by 4 into, and then for cos alone you have to write, so for cos power 2 is there, no? So 1 by 2 into pi by 2, because both are even, no? So pi by 2. So the answer is the area of one loop is pi a square by 8. Next, find the area of a loop of the curve x power 4 plus y power 4 equal to 2a square xy. See, this is something different. So for finding the area of one loop, let us take x equal to r cos theta and y equal to r sin theta. So if you substitute it here, you get r power 4 cos power 4 theta plus r power 4 sin power 4 theta equal to 2a square r square sin theta cos theta. Throughout you can cancel on r square. So simply you get r square is equal to 2a square sin theta cos theta by sin power 4 theta plus cos power 4 theta, which can further be simplified as this is nothing but sin 2 theta, no? A square sin 2 theta by sin power 4 theta plus cos power 4 theta. So r square we found out. So the formula is integral 0 to pi by 2 half r square into d theta. Only one loop area they are asking you, no? So 0 to pi by 2. Now suppose if you are not sure about the limits, you put r equal to 0. Okay, right, that is at the starting point and the ending point r will be 0, no, for any loop, because loop means what? We start from, see, this is the initial line, no? Initial line means we are starting here, wherever we go, whether it is like this or it is like this, we start from r equal to 0 and end at r equal to 0. If you are not sure how to find the limits, put r equal to 0 in the given equation. That will imply a square sin 2 theta equal to 0. So theta equal to what? Sin inverse of 0. That means theta equal to 0. This is one part. Apart from this, you see a square into sin 2 theta can be 0 for theta equal to pi by 2 also. For theta equal to pi by 2, it will be what? Sin pi. Sin pi is also equal to 0. So r equal to 0 when theta equal to pi by 2 also. So the limits are from 0 to pi by 2. This is one of the ways to find the limits. Okay, right. Now substitute the value of r square. So 2a square sin theta cos theta by sin power 4 theta plus cos power 4 theta. Now throughout divide by cos power 4 theta. So what will happen? This will become sin theta by cos cube theta by 1 plus tan power 4 theta. Okay, this can be written as tan theta secant square theta by 1 plus tan power 4 theta. Let me take tan square theta equal to t. That implies 2 tan theta into secant square theta d theta equal to dt. Okay, theta equal to 0 implies t equal to 0 and theta equal to pi by 2 implies t equal to infinity. So integral 0 to infinity. This tan theta secant square theta, instead of that I can put half dt by 1 plus t square. So 1 by 2 a square into 1. What is integration of dt by 1 plus t square? Tan inverse of t. So tan inverse of t within the limit 0 to infinity. So tan inverse of infinity minus tan inverse of 0. So this is pi by 2 minus 0. So the area is pi a square by 4. Okay. Next problem. Show that the area common to the circle r equal to a and the cardioid r equal to a into 1 plus cos theta is a square into 5 pi by 4 minus 2. See, r equal to a, it is a circle center at origin and radius equal to a units, and cardioid, this is a plus a cos theta, no? So it is lying horizontally on the right side. So the shaded portion is our common area that will come in two quadrants. So instead of finding the two quadrants, let us find it in one portion and multiply it by 2. Okay, so required area equal to 2 times area of OAB plus then OBC. Okay, BCO. Right. The first one is lying in the first quadrant. So limits from 0 to pi by 2. The second one is lying in the second quadrant. So the limits from what? Pi by 2 to pi. Okay, right. Half r square d theta means first one is in the circle, no, so half a square d theta. Second one is the portion of the cardioid, so half a square into 1 plus cos theta the whole square. Now the integration of the first one will give you a square into theta within the limit 0 to pi by 2, and here a square into, expand this, 1 plus cos square theta plus 2 cos theta d theta. So this is simply a square pi by 2, and here a square into integration of 1 is theta and integration of 2 cos theta will become 2 sin theta. This term I am keeping it aside for doing integration. So if you apply the limits for the first term, we will get pi a square by 2 plus a square into pi plus, okay, pi plus 0 minus pi by 2 minus 2 plus that cos square theta can be written as 1 plus cos 2 theta by 2. See, if the limits are from 0 to pi by 2, we can apply reduction formula, but here the limits are from pi by 2 to pi. So I am rewriting cos square theta as 1 plus cos 2 theta by 2 d theta. Now you integrate this term. For first two terms will be pi a square by 2 plus a square into pi by 2 minus 2 plus a square by 2 into, here it is theta plus sin 2 theta by 2, limit pi by 2 to pi. If you apply the limit for the sin theta, both the terms will become 0. For upper limit and lower limit it will be 0. Only this term will come. So pi minus pi by 2. So if you simplify, what do you get? 5 pi by 4a square minus 2a square. Okay, that's all. Thank you.